Are there, Praveen?
Yes. Yeah.
Okay, let's start so this part, we are going to go through different kind of design patterns that can be applied in different Android applications. And we are going to talk about some of the pros and cons. And we are going to see what we can do while we are asked to design a application. So one of the very first thing that comes with the design pattern is the MVC. I think everyone knows that it's like the model view controller. So here you can see the model, which actually defines the data structure, and it updates the view directly. And the view has sends the user input from the view to the controller, and controllers sometimes update the view directly, but most of the time the model will update the view. And whenever the user, let's say the user asks to see a calendar item or the event, and like user taps on a event from the list, then the view will tell the controller, hey, user wants to see the event detail. Then the controller will tell the model, hey, where is my event detail? And once you have the event detail, give it to the view, and the view will basically have the data, and it will show the event detail from there. In the meantime, controller, what it does is it will take the user from one view to the another view, from the list view to the detailed view, and show all the data. So the pros is no business logic in UI, easier to unit test, but there are a lot of problems here. It don't scale, separates UI but not model. Model is very much coupled with the view, and it violates single responsibility. Also, the interface segregation solid principle. So these are some of the pros and cons of the MVC. But if we look at our calendar application, what we are seeing as example here, how we can design our calendar application. We can have a model where we'll have a event list model, event details model, and the event data over there. Then we can have another, in the view section, we'll have all the layouts, all the XML files, resources. If we have any custom views, we can include there. And what the controller will have is the event list activity, what we can consider as our main activity here. If you want to don't include in splash activity, then event list activity can be our main activity. And then we'll also have event details activity. So whenever something happens in the view, that's basically happening while it's in the event list activity or details activity. And if event list activity needs to start the event details activity, it will start the event details activity and tell the model to update the view, and the model will update the view. Now we look at another pattern, which is the MVP, which is model model view presentation. So the difference is here. So the presenter actually plays a big role here. If you notice, like there is no connection between model and view. That means whenever model gets changed, it lets the presenter know. Or if presenter wants the model to be updated, it directly tells the model like, hey, update your model. Same happens to the view. Like whenever user action happens, it goes to the presenter, and the presenter updates the UI directly. So whenever, in this case, what's happening is like viewer saying, user is saying like, hey, I want to see the event details. And it what the presenter does is ask to the model like, hey, where is my event detail? The model say, hey, this is your event detail. The presenter says, all right, I have the event detail. I start the new activity, and this is the data, and the view will just show the data. So the pros, it's complex tasks split into simpler tasks, smaller objects, less bugs, easier to debug, testable. The cons is model can be reused, tied to a specific use case, and view and presenters are tied to data objects since they share the same type of object with the model. And if we look at this for our calendar app, it will pretty much look the same as the MVC. It is the only difference is like how the communication is happening between presenter and view and presenter model instead of model is updating the view. So it's pretty much the same. So you will have some model classes, event list model, details model, then all of your XML files like layouts, resources, custom views goes to the view portion of your design. And finally, the presenter will have the event list activity and details activity. And whenever either of this activity needs some data, it's going to grab the data from the model and it's going to show the data in the corresponding view. Okay, so these are like two of the very common architecture that you can actually apply, not even Android application, pretty much any application. But for Android, like it is different than other applications, because the way things work is we have to go through the whole life cycles methods here, and the application get destroyed, the activity or the fragment that gets destroyed when you rotate the device. So considering all these different scenarios and different things over the time, one of the most popular Android architecture is the MBVM. But anyway, I just want to talk one more time before going to the MBVM is like what is the difference between MVC and MBP? Here you can see in this photo, it's like in the left, MVC model is updating the view, and in the MBP, you can see that actually presenter is responsible for doing everything, for grabbing the data from the model, updating the view. All right, so now let's go to the MBVM we just started talking about. So what is MBVM? MBVM is the model view model. So so in the MBVM design, the first thing you will have is the activity or fragment. Here you can think about our event list activity, where you select a day and it will show all the list of events. So you can say event list activity. And then we can have a view model, or you can also say calendar activity, as you see in the slide. Either way, whichever you name, it's totally up to you. Then we will have a view model. So a view model object actually provides the data for a specific UI component, such as a fragment or activity. And it also contains all the data handling business logic to communicate with that model. So for example, the view model can call other components to load the data, and it can forward user requests to modify the data. The view model doesn't know about UI components, so it isn't affected by configuration change, such as recreating an activity when rotating the device. So view model doesn't have to care about what's happening in the activity. It doesn't aware of any of those things. All it cares about is, I'm getting some request, I'm just going to send that response. Now, we also have one other thing, which is the live data that is incorporated in the view model. Why we do this? Because so what is live data? So live data is an observable data holder. That means other components in your app can monitor changes to objects using this holder without creating explicit and rigid dependency paths between them. So this live data component respects the life cycle state of your app's components, such as activities, fragments, and services, and includes cleanup logic to prevent object leaking and excessive memory consumption. Remember, live data field is lifecycle aware. So what is happening? Let's see, this activity is subscribed to a view model or getting the data from the view model, and it is a live data type. That means whenever this data is getting changed in the view model from another application or from another place, it is going to call the onChange method. It has the onChange method, and onChange method, when it gets called, it is going to reflect all the information that is updated in the view model. But remember that if you're already using a library like RxJava, then you can keep using them instead of live data. But you also have to make sure that to pause your data streams when the related lifecycle owner is stopped, and to destroy those streams when the related lifecycle owner is destroyed. That means whenever activity is getting destroyed on the onStop method, you have to say like, well, I don't want to get data from this stream anymore. If you don't do that, what is going to happen is viewModel is going to send like, hey, data got changed and the activity doesn't exist anymore, so it's going to crash. So that's why live data is a good example to have instead of RxJava. If you're making a new application, it's good to go for the live data. In that case, you don't have to handle those things manually, because we already know that live data is lifecycle all the lifecycle method hours. Anyway, so now the question is, we have the event list activity or the calendar activity. It is saying like, hey, give me the list of all the events for this day, and viewModel is giving the day. But where the viewModel will get this data? So to get that, if you look at this photo, what's this diagram, what's happening here is we added one more thing here, is called repository. But the thing is, there is a reason we are adding the repository. But what the viewModel can do, it can just directly ask for the data using retrofit and the web service to design from there. So that can be the very first idea, that it can directly call the web service, the viewModel directly call the web service to fetch the data and assign this data to a live data objects. But remember, if you do that, that actually violates the separation of concern principle, because viewModel is responsible for doing multiple things here. We don't want to do that. So what we want to do is we want to delegate this data fetching process to another module. And that module here is the repository module. So the repository module, it will handle all the data operations. And it provides a clean API so that the rest of the app can retrieve this data easily. They know where to get the data from and what API calls to make when data is updated. So it's absolutely repository's responsibility to figure out where this data is coming from. viewModel should not know anything about it. All it can do is ask for some data. It's now repository's responsibility to get the data from whichever portion they want to. So right now it is getting data from the remote data source. That means using some library, you can use the web service to get the data. So so what happens then? So if you look at the whole workflow again, our event list activity says, hey, give me the list of events to the viewModel. And the viewModel is saying to the repository that, hey, can you give me all the data? So the repository layer then is making a network request of the UI layer of the UI thread in a different thread, because we don't want to do the data fetching operation at the same process on the UI process. If we do that, UI is going to be hang, application is going to crash, a scrappy system. So the repository layer is in charge of moving the execution of the network request from the main thread and posting the result back to the main thread using a callback. Now, our viewModel doesn't know how the data is fetched, so we can provide the viewModel with data obtained from several different data fetching implementations. Also, another thing I mentioned here, dependency injection. So the repository class needs an instance of the web service to fetch the user's data. It could simply create the instance, but to do that, it also needs to know the dependencies of the web service class. So for that reason, it's better to have your own dependency injection library there. So for dependency injection, you can it allows classes to define the dependencies without constructing them. So at runtime, another class is responsible for providing these dependencies. So you can use Dagger or Hilt, one of the dependency injection library for this purpose.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your free webinar slot today